So my name is Sean Smith. I'm speaking today with my buddy from Eclipse Foundation, or Eclipse, Gunnar Wagenknecht. And we're going to talk about EclipseLink JPA for NoSQL, Relational, and I put in beyond because there's actually some other stuff that we actually do that comes out of this work. And I'll just introduce who we are, and then we're going to do a bit of back and forth in terms of the content. So I'm with Oracle, and I'm a product manager for TopLink, and I work on a number of areas in TopLink. TopLink Grid, which is scaling out JPA into large clusters using Oracle Coherence. The Oracle Golden Gate Adapter, which is synchronizing databases and in-memory coherence caches using JPA. And on the work we're talking about today, here, the NoSQL stuff. You can see from the slide template that this is a sort of Eclipse-oriented talk. We both work on Eclipse, Gunnar and I. Myself on EclipseLink, which is where we actually develop TopLink. The majority of TopLink is built in open source. The EclipseLink project is the project at Eclipse that we do that work in. And I work on EclipseLink, and then there's a number of associated projects that come up. So for example, the DALI project, which is JPA tools, I work on that, and everything else to do with JPA I like to get involved with. And Gunnar.
Yeah, hi. I'm Gunnar. I work at Echido. We are an Eclipse Foundation member and have a couple of Eclipse projects where I'm committing on and contributing to. As our daily business, we're doing internet web applications in the e-commerce world, and that's why I also got interested into EclipseLink and investigating, especially the stuff we are talking about today.
So I'm going to just give you some context setting here. So we're talking about Java persistence, and for most people, they think of relational databases, but on the EclipseLink team, we have a broader definition of persistence. So for us, taking an in-memory live Java object and persisting it or putting it into some sort of durable format like database or XML file or JSON document, that's persistence to us. So it's a little bit more general. So the idea that we can go from a Java object like customer there into a table or into an XML document makes sense. There's specs for two of those sort of transformations. There's JPA, the Java Persistence API for relational. There is JAX-B for XML, of course. And it turns out, if you think about what the relational side is, it's OR mapping, right? OR. And the XML mapping is OX mapping. And when you put OR and OX together, you get XR, right? So XML relational. And so the DBWS feature of EclipseLink is an XR service. So if you want to get relational database data over a web service, and you don't really care about objects, you just want XML, then that's what that feature covers. But I won't talk about that today. We're going to focus on, well, we're going to start with relational, right? So the relational component for EclipseLink. But today the talk is going to be about NoSQL too. So what we've been working on is JPA support for mapping Java objects obviously into relational and then mapping them into NoSQL databases. And you can see from my little iconography down there, there's more than one kind of NoSQL database, right? So we're talking about different shapes. And we'll talk about that, I think, coming up. It'd be great to have JPA access where I can take Java objects and just put them into NoSQL databases, get them back, work with them, change them. But I don't want NoSQL to be a second-class citizen. I want it to be on a first-class basis with relational. And so what we really want is that. I want Java applications talking to JPA layer in EclipseLink where data is coming from different types of data sources. So this is sort of a polyglot sort of discussion, right? I want data to come from NoSQL, relational. I don't really care, but I want the programming API for me as a developer to be nice and simple and to be a singular API. So JPA itself, it's a standardization of common practices. So it's been around a while now. I work on TopLink, which had its own, I guess, proprietary or native API, called the native API. There was Hibernate, had its own API, and it still is hanging around, right? For some reason, people keep still using the old API, even though they support JPA. And what happened was these people came together in the EE5 timeframe under the EJB spec auspices and created JPA 1.0. So it was sort of a best of breed. What are the common practices? It was a non-ivory tower solution to a problem. Because if you've been around long enough, you saw EJB CMP, container managed persistence, kind of heavyweight. People didn't really want to use it. They're using TopLink, they're using Hibernate. So JPA standardized or came up with a standard for the core functionality we can all agree upon for POJO persistence. And so it's sort of a meeting of the minds. It works in Java SE, EE. EclipseLink works in OSGi. We're also part of the OSGi enterprise JPA spec, so we're pretty available everywhere, pretty much. So these are the moving parts. and we'll see them. How many people here are actually JPA developers or use JPA? Okay, almost everyone. Okay, so for the 5 of you who aren't, this is sort of the high level, right? You've got your classes, you've got some mapping metadata, XML or annotations, you got your tables, and of course we have the provider, the JPA provider in the middle, going back and forth, right? What's nice about it, of course, is it has a nice straightforward API. The API is actually fairly small. The query language is a bit more complicated, or more full feature, but the API itself is pretty small. Remove, persist, merge, commit. We have the JPQL, which actually is very nice, very handy, and we'll see how that fits in. And it works in both container and out of container, right? So we have a contract. So if you're in a container, you get certain nice integration with JTA and so on. So, is it you?
NoSQL.
Okay, we're going to fight over who says what. So, okay, over to you.
Who already worked with a NoSQL database? Oh, the other five.
The other 5, okay.
That don't know about JPA, likely. Yeah, so NoSQL databases are becoming increasingly popular. So there are many around, and that's actually the difference, the challenge. It's very difficult because you have to learn with every database. You have to learn a new API, and it's kind of challenging, especially if you're developing. Like we are a consulting business, and you have many clients, and then trying out different technologies. You have to educate your people every time you're just trying or using a new NoSQL database, right? And every database is different. There's no common definition. There's no standard, right? And it's not a negative thing. They are pretty new and they are innovative, and that's actually what happens when new things appear, right? So it's actually very interesting to cover all those NoSQL databases into the JPA standard, or actually to support them using EclipseLink. That's not an easy task to do, but EclipseLink found a way to do it, right?
Right. So what we've done is, thank you. This one, sound. This good too. It's all live. Okay. So I can't even see the slides over here. It's not going to work. Okay. So there's a bit of a history here. So EclipseLink has been around a while. It was open source from Oracle TopLink. I used TopLink for Smalltalk in like 96 or 7 timeframe. So the architecture of TopLink's been around. The idea of ORM has been around. As part of the evolution of EclipseLink, or at that time TopLink, we actually introduced support for what we call the EIS feature, Enterprise Information Systems. So we talked through a JCA adapter, mainframes. We could talk to packaged apps, your financials, whatever, through JCA. So we were able to transform Java objects into XML or structured data to persist them, interact with these non-relational systems. So I believe Gunnar was harassing us to EclipseCon, saying, why don't you guys have NoSQL support? Like, where's the NoSQL support? And so we went back to the development team, and one of our senior engineers, James Sutherland, basically said, the EIS stuff is just like this. This NoSQL stuff is very much like our EIS support. And so in short order, James had come up with a basic implementation to support NoSQL. It turns out that this code that we had lying around for years, which we really weren't using, was exactly suited to do what we wanted to do with NoSQL. And so what we've done is we've introduced a little bit of extensions on JPA. For example, we have an annotation that's at NoSQL. You can stick on a JPA entity to say, this is an entity, but in addition to being an entity, i.e. persistent Java object, it's also going to be stored in a NoSQL database. And the reason we have that is because there's extra information we need to know, and I think we'll see it coming up, but the formats are differing in different databases. So, you have map structures, like in Mongo, you have columnar stuff, you have graph databases. They're all a little bit different in terms of the format. So we kind of need to capture what does that target format look like. So we have an annotation that lets us configure that. The key principle that we're supporting here is that we want to leverage what's available. So I'll contrast this later on with Hibernate OGM, which has a different philosophy and approach. But our approach is if you buy Mongo or you buy Cassandra, your goal is to leverage Mongo and Cassandra. That's what you're investing in. And so we're not trying to provide some sort of magical compatibility layer across these databases. So we're going to go with what we can do with that database. If your database has a query language, then we'll translate JPQL into the query language if we can do that, and to whatever extent that language expressibility captures JPA semantics. If it doesn't have one, well then you're probably stuck with gets and puts, so basically primary key access. So we're not trying to take over the world here and provide this magical, interaction layer. It's trying to let you get at NoSQL database data. So we started off with MongoDB and Oracle NoSQL. Mongo at this point has a pretty good market share, and I work for Oracle, so that makes sense on the second part.
So, who already heard about MongoDB? Who already heard about Oracle NoSQL database?
Okay, that's the 5. 5 is a constant 5. Okay.
Yeah. So there's a challenge for your marketing.
Yeah. Who here works for MongoDB? No one. Okay. Just wondering. So you can say whatever we want to say. So the final point is we also want to mix things together, right? So we already had this ability for many years, and we support this in EclipseLink, where you can actually have multiple relational databases all sort of merged together. We used to call it session broker, but we call it composite persistence unit. So some objects or some entities are living in Sybase, some of them are living in Oracle, and we can have them all in one persistence unit. You can lazy load across database technologies, that kind of thing. You can use transactions across databases, all this kind of stuff. So we want to extend that over to NoSQL databases. Like, why not? So why can't I have NoSQL source data and relational data? It's all just Java objects in memory, so why can't I mix them together? So this is the sort of the polyglot persistence, right? And if you follow, I think you have a slide with a quote.
Yeah.
Maybe that's the next one. No, it's not. Okay, I'll say it anyway. Yeah. So, if you read like Martin Fowler, and the book just came out, right? They're all about the realities of enterprises have lots of data. We know that, right? We're Oracle. You have lots of data in different databases. You want to get at it and use it. And this is kind of the reality, right? This is not, you should just buy an Oracle database and your life will be perfect. That's never going to happen. You're going to have departments and companies you acquire, and Oracle's really good at this, we know. You're going to acquire a company that got some database, you're going to have to just live with it and deal with it. So we need a way to have this sort of polyglot support in JPA.
Right. And so as Sean already said, the goal of EclipseLink is to leverage what's available, and not all concepts automatically apply to the NoSQL world. Right? So there are core concepts of JPA that apply very well. Right? So you have the entities, your objects that you just persist in the database, right? And in some NoSQL databases, you can embed the objects that you can persist complete object trees into the database, and that's actually quite a benefit for some data, right? And we have a couple of slides later on to explain when to use one or the other technology, right? Some concepts depend on the database, like JPQL, the query language. Some NoSQL database don't have a query language, they just support put, get, push. And others, the relational just don't make any sense at all in the NoSQL world. Yeah. So let's look at some, we already talked a little bit about the queries. So with EclipseLink or with JPA, you can do two types of queries. Of course, there's JPQL, right? It's a query language, and there's some support in EclipseLink to actually translate that into queries that work in the NoSQL database in MongoDB, for example, right? You can do simple queries in JPQL and that work in Mongo. But there's also the possibility to do native queries, optimized queries. If you actually know you're sticking with that technology, you can always do a native query, which actually means a JavaScript query in the Mongo case.
Right, and then obviously the relational world is just it's SQL call, direct SQL call, right? So you can support it in the JPA spec. There's a place that says put in a string here, and we're going to pass this to the database and handle the results. So that string with a query could be anything. In fact, in our case, it's let's say a Mongo query. So.
Yep.
So here's an example class, a brief intro. It doesn't look that strange. There's some changes here. We mentioned before this NoSQL annotation. In this case, we're going to map this to Mongo. So we've set the data format type to be mapped. That is, it's got key value structure. It's not indexed, for example. Structures are actually named. The properties have names. We have support for ID generation. So if you just say generated value, we're going to use the Mongo native UUID generator, which is a nice feature because it's easy to use. And you'll notice Mongo also has this, likes to call the IDs _ID. So in JPA, as you know, there's a lot of defaulting. So ID, in this case, just the ID, no prefix, will be mapped to a property called ID. If we want it to be actually mapped to the field ID, we put in the @field. The reason we put an at field there was mostly because the at column doesn't make sense. You could use it, and we know it actually works. So if you put an at column, the name is this. It's kind of the same thing as saying the field name of the Mongo object is this. But at column has a bunch of stuff on it that makes no sense. You know, field length, database data type, all kinds of stuff that's relational. So we said, okay, let's just keep these two things separate because this is a very simple requirement. Other than that, it's just this is just JPA. Basics, one-to-ones, element collections. It's not too strange. So if you're a JPA person, this shouldn't scare you, right?
Right. Yeah, and I already talked a little bit about the queries. Here are some example queries that are automatically translated into Mongo NoSQL queries, right? But you can also use the entity manager to actually create native queries that use Mongo constructs. And you pipe in the class, get a single result back, and then you execute a native MongoDB query.
And what's nice about the native query support and named query support is you can declare them in the file, right? You declare them in the top. You can declare them in the mapping file. You can declare them on the objects. But if you declare them as named queries, then the callers don't know. So you could hide these native queries off behind the name, like do this query, and insulate the end user. So if you're migrating, and this is I think the topic that Gunnar's going to talk about, if you're moving between these two databases, there are some strategies for keeping your Mongo or your Oracle NoSQL coupling contained.
Right. Okay, so I prepared a little demo that shows one of the projects that I'm doing is I'm doing a lot in OSGi, and we're using Gemini to actually persist data. Just pass it off to an OSGi service that stores it in the memory, right? And I'm using some OSGi services to actually replace that service at runtime with an EclipseLink backed service that persists the data into Mongo database. Okay, so that's a JPA project. It's actually an OSGi bundle, but you have the persistent XML where you specify the data of the persistent unit. You give it a class.
How's the font way back there? It's a little bit
Too small?
I thought so. Yeah, crank it a little bit. We didn't get the big screen, Font. Looks good.
So, just need to find the right one.
Oh. I thought for a minute it's all in German. Okay.
No, it's a text editor.
It's text font. It's done under general. Breaks out. I know this. It's under general. It's text font.
Yeah.
Next one. There you go.
Let's try this one. A bit better in the back? Okay.
Any more won't fit.
Yeah. So it's actually a very simple persistent unit. You give it a class, and then you specify the database connections, and that's actually the difference, right? It just set the target database technology, which is a Mongo platform, right? And say, hey, I need a Mongo connection spec, which basically knows how to read those properties for Mongo, giving a host name of the Mongo database server and a port, right, and the name of the database, and that's it, right? So there is an entity over here that is persisted into the database, and I actually used intentionally. I used the column annotation over here just to not only to demonstrate that it still works, but it also allows a very great setup, because when you start developing applications, you can, and your object model is not fixed, right? You're still prototyping it. It's actually very convenient to use Mongo for that, because you don't need to deal with schema issues, right? And once your object model is kind of set up, you just start actually working on the relational model for that.
So if you're using NoSQL for prototyping.
Yeah, for prototyping. Okay, so let's just look at the demo. Starting the OSGi framework. Okay. So it's a very simple web application. Actually, it's just a servlet or a JSON in that case, where I can just enter some greetings, submit them, and they are actually collected in a hash map, right? So if I restart the server, they are gone. And what I have here, I have just start the JPA bundle that I have over here, which actually brings in the service, and then.
So the advantage of OSGi is he's dynamically swapping out the persistence support.
Yep.
Right, he's swapping out a jar, a service.
At runtime.
At runtime.
Right. So, and what actually happens, as soon as I swapped it out, EclipseLink kicked in and started the persistent unit. Just to refresh, I actually have some data already in the database from previous exercises. And now let's look at the how this data is laid out in Mongo. So it creates, Mongo has these concepts of collections, which basically map a little bit to tables. So it creates a collection for the entity, right, and also defaults to the entity name, like it does in the relational world. And then it creates the documents in Mongo, right, and it actually has the attributes right as they are. Right, so you have the ID that's auto-generated, you have some text and other attributes of the entity that are persisted one-on-one into MongoDB. Right, so there's no serialization or XML data format, it's just put into Mongo as the object really is, so that you can use Mongo queries to go over the data.
Okay, so we have another demo coming up in a second here about on Polyglot, but the issue here is that it's funny, you know, I'm doing his slides, he's doing my slides somehow. This is working out. So anyway, your slide says that there's different kinds of database technologies, right? So I said this earlier on. We want to be able to get access to all database technology. We don't really care what it is. In your enterprise, you're going to want access to it. There's going to be maybe interesting data in a MongoDB database or some NoSQL database, like image stuff, film, who knows what it is. It just happens to be captured more naturally in that database technology. So you want to get at it. So I think your point is around the choices. So how do you make the choices, right?
Yeah.
So
yeah, that's a very important choice, and actually it may turn out that the choice you made once in a time may just not be, maybe another choice in the future. So right, if you're actually Martin Fowler made a good point in the question is not where to store the data. The question really is about how I'm going to manipulate or how I'm going to query the data, because that actually gives you an indication of what capabilities the data store must offer, right? Of course, if you go Polyglot, there's a cost of complexity in your application in the world, because it's not that you can separate it like I have this application into that data. In large corporations, you actually have to have a single application working with different persistence technologies. Mm-hmm. Right?
Right, and the thing with querying is very key, right? And Martin Fowler does cover this, I think, on the website. And then he has a new book come out, NoSQL Distilled, where he's basically doing a survey of different database technologies, sort of what's the rationale, what do they do. It's a pretty good overview so far. But the question of what are you going to do, how do you access your data? So there's it used to be is it mostly insert, or mostly read, or mostly query, or whatever? So you still have those concerns. Relational databases are awesome at large, complicated queries, right? That's what they're really good at. If you're going to do large, you know, multi-table join type queries, that's great for relational. It doesn't work so well in the network or in, say, document-oriented, right? This is not what they're built for. If, on the other hand, you're accessing data frequently through relationships, like once I pull in the customer, I want to quickly get at associated stuff, and it's in a network database, you can easily navigate very cheaply to those things. Good choice. But one of the things that we're offering here with this approach of using JPA is the application doesn't look much different, right? So we're offering it's an abstraction layer for sure, in that we're hiding the the guts of, say, the Mongo API or the Oracle NoSQL API specifically. You don't have to learn that API. If you move between database technologies over the course of a project, maybe through prototyping to production, or even over time you need to move a certain piece of it to a different database technology because your boss tells you that's the corporate standard and you're going to like it, it should be much easier because you're working through a relatively standard or extended standard API that you're familiar with. So this is really the goal here. Again, it's not, it's sort of to enable choice, right? We're trying to give you openness here.
Right.
So again, we've said this, each has their own strengths and weaknesses. But this multiple database is very interesting. So I think I mentioned this earlier. We have always had this multi-database support. We originally wrote it way back before JPA. When JPA came out, it didn't have this concept of multiple database connections. It was one persistence unit gets one connection. We actually had customers pushing us to add this to JPA because we didn't really have it, and the old technology, the old stuff we had in TopLink didn't quite work with JPA. So we came up with this composite persistence unit. And I'm going to give you I think that is the next slide here. It says demo. It says demo, okay. So I'll give you a demo of a composite persistence unit. So I'll show you what composites look like, and I'll show you what the application code looks like, and what it looks like in terms of what you see in your application. And I'm not as talented as Gunnar, so I will be showing you sexy console output too. I'm a server guy, so. Okay, so what I've got is I've got a Mongo database persistence unit. Okay, and it's not particularly exotic. It's got some classes. I got addresses. I've got customers, orders. Let's zoom up here. So I've got an order. You see, this is actually the author is James Sutherland of this, and this example, or at least the fully Mongo version of this, is currently available in the EclipseLink examples Git repository. The Polyglot version actually I haven't committed it yet, but you can download most of this code here. So it's a NoSQL entity. It has generated UUIDs. It has collections of order lines. And notice their element collection. When you say, as we said before, when you say element collection in JPA, that means these are an aggregate structure, right? They're owned by their parent. And in a NoSQL database, in the document database case of Mongo, that means that the collection of order line objects will be co-located in the same document inside of the order document. So it's one thing, right? One key for all these guys. And so we basically honor this annotation by putting things together, and we'll see that. So we have this simple set of classes, just 4 of them. Looking at the persistence XML, it's similar to what Gunnar had before. Same thing. A database target is Mongo, the connection information, and then the usual TopLink stuff, or EclipseLink stuff. So I've turned the logging levels up pretty high here, and turned off some of the stuff that we show in each logging entry, just for cleanliness, but it's pretty normal. And so that's one persistence unit, and that will produce a jar. So in my build, I'll get a jar, mongo pu.jar. And I have a relational persistence unit project here in Eclipse. Has a couple classes, the discount and product. And if you notice, what I've done is, order lines have, where are we going here? Has a one-to-one to product. So every order line has a product. The products are actually not in this persistence unit. They're actually going to be in the relational persistence unit. These are going to go into, in this case, into Derby, embedded Derby database. So I have these 2 objects in different technologies, and I have a relationship across. And I used the DALI tools here that are in Eclipse. And DALI complained bitterly that you are referring to an entity that is not in this persistence unit. Like, you were wrong. Red marks. So I brought up just so you know this, if you try this out, you can bring up the properties using, actually, I'm sorry, I gave it to you, it's not JPA. When using DALI, when I was building this, you would see JPA here, and you can actually control the error. So I went in and I turned off that error. So every single error that DALI puts out, like target entity is not in the persistence unit, I changed it from error to info. Like, yeah, I get it. I believe we've implemented that for Doug Clark, who really hates to see red marks in code he knows is fine, right? Or even yellow marks. So we can dial down the messages. So DALI doesn't understand that you've got multiple persistence units in the composite, so we can just sort of tell it it's okay. So anyway, so I have Mongo, I have relational here, and relationships between the 2. Both of these produce a jar, and they build, and I have this composite persistence unit. This is where I put these things together. So just to point out, these persistence units here, I don't think they have the setting. They don't know. Oh yeah, this guy does. We actually have a property here saying this Mongo PU, he's a member of a composite. So you don't have to declare this, but you can, for documentation purposes, say this persistence unit should not be run by itself. It's going to be a piece of something bigger. I think if you try and run this by itself, EclipseLink will tell you, hey, this is a component persistence unit. You didn't really want that. But up in the composite, let's close everything here for a second, just clean up. In the composite persistence unit, I have a list of the jars, right? So I path them. If I'm in an EAR or in an EAR environment, for example, I would path these like this. In this case, they're just here on the file system. And I say this is a composite persistence unit. This guy composes together sets of mapped entities. And it has notice there's no connectivity, there are no classes here. This guy just is really truly composing together these things. And I have a small example. So what I'm going to do is I'm going to run, I think it's all to go, right?
Yeah, it's ready.
So let me show you what this demo does. So this is as sexy as it gets. So, bear with me here. I'm going to do some plain old JPA, create an any manager factory for that composite persistence unit. I'm going to create an any manager, begin a local Java SE transaction, right? Create a new product. So I have 3 of them: installation, shipping, or 4 of them, net, machine. I'm going to create a customer, which is a NoSQL. It's mapped into Mongo. I'm going to create an order, which is also going to be put in Mongo. And then right here is where it gets interesting. So I'm going to create 3 order lines for that order, and I'm going to associate with them these objects that are not actually going to be stored in that database. Right? They're going to be in the relational database. They're going to be in Derby. I'm going to persist a lot of it and just commit. Okay, so I'm just going to run that for a second. I'm going to put this in debugger so we can watch it happen here. So let's run this. Now this is going to be really real estate challenged here. Okay, so what you see in the console. There you go, sexy console. Okay, so you see us doing some stuff, sequence number generation. This is the relational side, so we're getting that for these products. And you'll see here, we see a mapped interaction. We're seeing us persist into the customer collection. We're doing an insert into Mongo. And we're putting in the customer whose ID has been auto-generated to that, and that's the name we gave him. We see some interleaved, interestingly enough, in the console anyway. We see some inserts into the Derby database. And these numbers, the primary keys here, are being manufactured by that sequence generator, the table-based sequence generator. And we see here now the order goes in, so we see an order get inserted also. We know its order ID, we got all the info here. And notice down here, this is the really cool part, order lines has an object, and notice that it has a product, but no longer, it doesn't have product anymore, it has product ID. So just like when we do JPA defaulting on column names when we're for doing joins and foreign keys, we're appending ID on here. And you notice the object is replaced with its number. So if we look in the Mongo Explorer here, yeah, I need to,
No, that's not.
that is not it. Here we are, I have to disconnect and hook up. I need to Java 1.
2012.
Okay, so I have the order, and there's my single order. So down here, I have these order lines, and you'll notice they have product ID as 201. So I've broken the links. I've broken the physical memory pointers right between the objects and replaced them with just the ID of the target object. So I can go and recover this later. You'll also notice that where'd that go here? The customer that actually owns this order is also referred to by its ID. So the same thing, even between documents, I now have inter-document links essentially by embedding these the IDs rather than the actual full objects. On the other hand, order lines are actually embedded right inside of this order document. So jumping back into the debugger again, what I'm going to do is I'm going to close off that entity manager, and I'm going to clear the caches. So EclipseLink is very pro-cache, right? We very aggressively cache. So all that data we just created is all in the L2 cache, the shared cache in EclipseLink. So to force EclipseLink to go back and query databases, I'm going to just clear the caches out so we don't get any hits. So I'm going to call it evict cache. That's a JPA2 standard API call to clean out the cache. Let me just step down here. So we're going to what I'm going to do now is I'm going to create a new entity manager. I'm going to go find that order. I'm going to go query him from Mongo, and then I'm going to iterate over the order lines and print out the order lines. Okay, so we'll just take a look at what that does. Actually, I think I will clear the console here and just let this go, actually. Okay, so let's take a look. So what we saw there was, we see a query. We're doing a find on order with a primary key we know. We get it back, and then you see a series of selects. And I'm not trying to make this efficient. But what's happening here is, as we're iterating over these objects, these order lines, we're resolving the reference, which was we had the ID. Where we have in EclipseLink, we have these little value holders, proxies. We touch the proxies fire. They say, I need product 203. And what's nice about the way EclipseLink works is, at this level, it doesn't know where that's coming from. It just knows I need to resolve product 203. It goes off to a certain layer. At a certain point in EclipseLink, we go, left or right. We go down towards Mongo versus relational. We produce the appropriate query. In this case, a relational select. We pull it back in. We put the objects together, and you're none the wiser, right? So, printing out the order and the various order lines, we have the results or the descriptions from these guys. So this is very, it's kind of weird to see these weird looking interactions happening, but in my application, which I'd rather focus on the application than sort of the weirdness of console, but this is just JPA. There's really nothing sexy here, right? This is not rocket science. All right. So I think that's that section.
Yep.
Okay. You're going to stay there? Okay, stay there.
Yeah, I'm just talking a little bit more about the best practices or experience here from using this stuff, because that wasn't just a fancy idea or project that I came up with. It's actually, we really had a need for this in one of our projects. Actually, we use it in a couple of projects now. It's productive in a smaller application, but we are also looking to put another application into production with EclipseLink 2.4. So, as I already said,
Yeah, I have a question. So as I know, the transaction today of Mongo is not the same as the relational database. How you are handling this?
I'll talk about that in just that slide, actually. So the question is, the transaction model in MongoDB is not the same as in relational databases, and that's actually very, very important thing to remember. It are two worlds that you have. You have the relational world and you have the NoSQL world, and within NoSQL, every NoSQL database is different. So Mongo actually works like when you're working with Mongo, you need to think like auto commit, right? There's no transaction, even though you have the transaction API in JPA. Like you call begin transaction, you call commit transaction, right?
So all you're doing there is really staging the changes.
Yeah, it's just staging. They are really, as soon as the command is executed, it's right in Mongo. There is no rollback or something, right? But then again, there are in Mongo there is additional API that actually allows some fancy atomic operations like replace or whatever. There's no such thing in JPA yet.
Right.
Right. But for the simplest case, especially for the sandbox development, if you're thinking auto commit, it's a very nice way to start prototyping your model, to start prototyping your application. And once you have the domain model all set, you can start working on the relational schema, right? So that's one way. The other way is, of course, the Polyglot way. Right? And very, very important statement is, don't be cool just because you can. You really need to look at what your clients can do, what your colleagues, your coworkers, the people in the company actually can do, and sometimes it's better to stick with relational databases, right? Just because the knowledge is already there, especially when you're transition an application into production and suddenly recognize that none of the operators or administrators has any MongoDB experience, then you are actually confronted with a new problem, right? So we had this with one of our clients, and so thanks to JPA, we were able to quickly exchange that or migrate the application to MySQL again in a controllable amount of time. Right? Yep. So Sean already talked a little bit about the tools.
Yeah, so the tools I'm most familiar with, of course, there's tooling in NetBeans, JDeveloper, Eclipse. I'm involved with the DALI tools, which are part of the Web Tools platform. So if you get the Java EE edition of Eclipse, that's the Web Tools platform release. And DALI actually is quite useful to a degree. I mentioned already that it's going to give you complaints about certain things that it can't understand about NoSQL. But fortunately, you can sort of suppress those warnings. If you're working with DALI, it's very smart because in a relational world, it looks at the relational schema, it looks at your Java object structures, it looks at your mappings, and puts the whole thing together and says whether you got it right or not, right? So have you got primary keys right? Are you referring to columns that don't exist? All the things you want to make sure are correct. So it's really synthesizing the three models together. In the NoSQL world, there's no schema, so we can't do that. But fortunately, DALI will work in the relational world anyway today, with or without a database connection. So if you have no database connection on the project, it just doesn't try and do the validation against the schema. And so basically, if you don't have database connection and using NoSQL database target, it actually doesn't hurt. Just don't put in columns and all these things, and it just really can't help you, but it doesn't hurt either. So it's actually pretty good. It'll still tell you things like, you're referring to things that don't exist, your configuration is wrong, you have a class that you've said is an entity, but it isn't in your persistence XML, etc. So there's still a lot of value there, but it's not a perfect fit at this point. I would still use it.
Yep. Yep. And then of course there are the database specific tools like we use Mongo Explorer in our demo. There's also a nice plugin MongoDB for Eclipse that I use in development.
Yeah. Okay, so has anyone heard of Morphia? No? Just a couple? So I hadn't heard of it till recently enough, relatively recently. The funny thing is, the first person I'm talking to at Java 1, I mentioned this NoSQL stuff, they go, have you heard of Morphia? And I'm like, oh, I just heard about this. So I went looking, it's a Google Code project, it's a fairly small project, and it's focused on MongoDB specifically, but it's taking a JPA approach, or JPA-like approach. So here's an example from, I snapped off of the Morphia webpage. It looks almost like a JPA entity. It has entity, it has ID, it has embedded. The object ID type is a bit funny there. They use that for UUIDs, although you could just use a string in EclipseLink, but they have a special class in Morphia. But what's strange about it is it looks like JPA until you look at the imports, right? That's where things go kind of weird. It's really similar except for the imports. So it's a few things to think about this, right? It's Mongo specific. So if you're on Mongo, you've got a JPA-like API on Mongo. That's great. But you can't mix and match it with anything else, right? So in terms of the sort of EclipseLink comparison, it's a Mongo-only solution. You couldn't mix in relational. You couldn't use other NoSQL databases. You're kind of married to this. The other thing that I found in looking at Morphia was it makes you manage the order of persist. So if you go persist, persist, persist in the wrong order, it's going to blow up on you. And I remember years ago looking at Castor, which was an older ORM framework, had the same thing, and I immediately left. Like the moment I have to worry about what order I do things in, I don't want to know. I just want to be a Java guy who writes some objects and goes commit at the end, and the world is all fine. So EclipseLink, we work out the order things have to be done in to make sure your database is in the right state. So it's a bit of a limitation there. It means it's just more of a manual technology with a bit of sort of sugarcoating on the top there. So in terms of sort of comparable features, EclipseLink is obviously multiple databases. Independent of that, I think it's a lot easier to use given this issue with the ordering. I thought that was really quite limiting. The real issue is they're almost the same thing, except that EclipseLink is actually based on an actual standard, whereas these guys are sort of making up stuff to be like the standard, and we're trying our best. Obviously, we're introducing things that are beyond the standard too. There was some discussion of should we standardize NoSQL? It's kind of like the GEE stuff with cloud. Yep. Should we standardize cloud? And everyone said, like, it's a bit soon. Let's try things out. Let's see what's working, right? So we're looking for feedback on this, for sure. Then there's Hibernate OGM. Anyone heard of OGM? Yeah? Okay, a few more. So this started off, it's a project led by Emmanuel Bernard, a very smart guy, focused on plugging in Infinispan, which is a data grid product from JBoss, as a in-memory cache. So it turns out that's just like TopLink Grid. TopLink and coherence, it's JPA with coherence for caching is a scale-out solution. It's a very similar kind of solution. The thing is that Hibernate OGM imposes a very specific data structure format on your database contents, and it's really not obvious initially. And so I try and phrase this, and it's a bit subtle, the distinction. So Hibernate OGM is trying to use NoSQL, in this case initially InfiniSpan, NoSQL database to store entities. Okay, that sounds reasonable. EclipseLink is trying to let you get access to NoSQL data through JPA. In other words, if you've got a NoSQL database, we'll let you map your objects onto that and get at that data. And Hibernate OGM is saying, no, the database will look like what we say it's going to look like because you're trying to store, you're persisting your entities. And I'll show you a screenshot from their site. The one thing they have that's very interesting, it's kind of a plus and minus in terms of philosophy. They're using a Hibernate search, they're using Lucene to do querying. So one of the problems with these NoSQL databases and no joining is it's hard to do complicated queries. The Hibernate OGM guys are basically indexing all the data in the database, right? They build massive indexes in Lucene. And then they use Lucene to do the query resolution. So they're trying to, in this sense, I mentioned it earlier in terms of philosophy, they're trying to add on a query layer on top of these databases to kind of normalize them. And our approach is, if it has queryability, we'll let you get it. That's what you bought. And if it doesn't have a query framework, well, then it doesn't have one. That's what you bought. So we're not trying to augment these databases. We're trying to let you get access to them. So it's a subtle difference. Here's a shot from the, if you go to the Hibernate OGM site and pull this down, what they're doing is they're actually deconstructing the objects into tuples. And I don't really know if they're doing this in Mongo yet. I think they must be doing it this way because that's the way it works. This is reflective of the way InfiniSpan stores data as sets of tuples. So breaking all the entities down to tuples, and then they're also reifying the relationships as separate tuples. So the associations between objects become another object in another cache or another database that they use for resolution. So it's really, if you just want to passivate your objects into a database, OGM is okay. If you and your enterprise had a department who said to you, hey, you JPA guys in EE, we've got this database over here you want to get at, then we're a better fit. So it really depends on what you're trying to achieve. That said, both of us are still in development, really. I mean, we all have some basic functionality, and I think that we have a core in EclipseLink 2.4, but both projects are still evolving, so this could all change, right? This might be, they decide after a while that this is working for InfiniSpan, but maybe it's not a good idea for something else. So we're at the end, where are we? We're pretty good. Okay, so this is new stuff, right? And our team, we're relational guys, so we have a lot to learn. So we're looking for feedback. So we may got some things right, some things wrong, some things not quite right, hopefully close. And so we're really looking for help with this. Like if this is interesting to you, like Gunnar, we're doing this because Gunnar told us to do it.
You have your own NoSQL database as well.
We have our own NoSQL database, it's true. But at the time, I don't think we did. I don't think so.
It wasn't public yet.
No. So Gunnar had a business need as a consultant. We're both in the Eclipse community. We know each other. So he kind of drove us to get something done, go beyond some ideas. So obviously, people with ideas can have a very strong influence on what our engineering team is doing.
Question 8.
Yeah.
On your example earlier on, you had then a relation or a dependency between these two projects.
Yes.
Which was one way.
It was one way.
Basically, you could depend upon some entities in one project within the other.
Yes.
So the obvious question is...
Can you go around?
Yeah.
You can go around technically, but the compile time thing is a problem.
Exactly.
That was the problem I had. Because currently, the way EclipseLink works with composites, it wants jars. This is just the way we implemented this composite persistence unit thing. It's like, take these jars, compose them together. So we have two jars that have circular references.
Yes,
it's problematic.
Generally is a problem to me.
It's problematic. Now the upside is the way around this. That occurred to me later on after playing with actually trying to build not circular but just dealing with the jar manufacturing was have the domain model in one project and put mapping files in the jars, just mapping files. Right?
That
So
will work,
yeah, it works. So just move the metadata into XML. And that way you have a model project that you include into your path. And then two projects that contain persistence XML files with just mapping files. And that should work because I believe that will work. So,
Yeah, it will work.
Fingers
the only problem is, of course, that you'll get an explosion of yards. just because you want this persistence, the meta persistence XML in a separate jar.
In a separate jar, yeah. And then, like I say, this is the current implementation. Because we had a need to meet, so it works. But I'm not saying it's the end solution. So, good feedback. Yeah. Okay, I guess we're going to wrap up. So, we only talked about 2 databases. There are more out there. We're looking at others. So far, these names are appearing on our list of interest. If that's not your list, we'd be interested to know what else you're interested in, and can you help? If you look at the code for Mongo, the database platform adapter we have, it's really small. Like, there's not a lot of code in the database adapter. It's impressive.
All right.
Okay, in the long term, maybe it'll be standardized one day, but not now. Right? Not now. Thanks.